Is it audible? So yesterday we discussed about second module in that important solar geometry like latitude, declination, hour angle, azimuth angle, zenith position, day length, local apparent time. So these things we discussed in our last class. Definition as well as equations. Only equations we are going to discuss. So there is no derivations, only equations. And using that equations, we are solved one important problem. So in the examination, you may get similar problems like that. So these are things we discussed yesterday. And also this is an important problem we discussed. And the next important topic in the second module is solar radiation on tilted surface. Okay, solar radiation on tilted surface. We already know that sun is not a flat, it is not a rectangle. Sun is a circular, and Earth is also a circular. It is a sphere. Earth and sun both are sphere, means circular three-dimensional object. It is not a cube, it is not a rectangle type projected object. So it is purely a sphere, earth and sun. So that whatever the radiations dissipated from the sun in all possible directions, it is reaches earth surface through some hurdles like scattering, absorption, reflection. Okay, so in some portion of radiations reaches earth surface, and earth surface, okay, normally for us it look like a flat, but if you see from the outside the earth atmosphere, it is completely circular, so that we are not consider earth as a flat. So flat, okay. So whatever the radiations from the sun, it is not fully focused on the earth surface. It need some inclination. We are okay, we are placing some collectors, okay, or some devices. Those devices absorbs the sun radiation, of course. But if you know, if you placed on the earth surface, okay, exactly on the earth surface, we are not going to get a more effective solar radiations on that surface. So that we have to make some inclination, we have to tilt that surface, that collector surface, okay. A collector surface now we have to tilt certain angle so that it will absorb maximum solar radiation. The best example, solar water heater on your roof terrace, or whatever the solar panels we placed on the roof, okay, it is not exactly horizontal, it is placed some inclination. That is what a tilted surface, a collector surface ಏನದಲ್ಲ, that is tilted, it is oriented, it is a oriented or tilted surface. That's why it is called as a tilted surface, okay. And a fully sun tracking surface means if you want to absorb a more or maximum solar radiation, we have to install a sun tracking system. Means that our tilted surface should follow the sun. Sun is moving along the sky, okay. So it is noon, in the morning sun is in the east, okay, and it is slowly moving along the sky when the time goes on, and exactly in the noon time sun is exactly on the top of our head, that is what zenith position. And again it is doing moving towards the uh, west, okay. So this is what the this tracking means the sun tracking surface should installed on our surface so that we can absorb maximum amount of solar radiation. So efficiency of the device will increases. Efficiency of the device or receiver is increases. And this sun tracking surface that always faces the sun receives the maximum possible solar energy at a particular location. So this solar radiation is always depends on the latitude and the meridian on the earth surface, okay. And a surface of a same area oriented in any other direction will receive a small amount of solar radiation because of solar radiation in such a dilute form. This the solar radiation is having a dilute form of solar energy, and it is desirable to capture as much as possible on a given area, so that we have to make it as an inclined surface. We have to see in a proceedings sections that measuring instruments, already we gone through our measuring devices, so pyranometer, pyranometer. So through that, so those measuring devices will give more readings when they follow the sun tracking system. If you place in one particular direction, only in a particular direction it is maximum, and when passes that particular direction, the sun radiations will slowly depleting. Okay, and because of the most of the solar collectors or solar radiations or collecting devices are tilted at an angle with respect to the horizontal, therefore it is necessary to convert data from hourly radiation, means from the measured devices on a horizontal surface, and which is by the some equations. Okay, so by using these equations, we have to measure first beam radiation. There are radiations. We already know that beam radiation is different, diffuse radiation is different, global radiation is different. So that whatever the beam radiation data is different, diffuse data is different, and global radiation or total radiation is different. We have to use different equations to solve this. Okay, for this first we generally taken a one common equation. You just remember this equation: cos theta t, cos theta t. Okay, so in most of the cases tilted surface is due to south, means always the tilted surface is due to the south. Okay, so you just observe in your solar water heater. So in the solar water heater observe madi, so it is tilted in such a way that either it is a south or north. The tilting angle towards south or north, not east or west. Clear? The flat surface should exposed to the east and west. It is not north. Clear? The inclination, whatever the inclination we made, it is towards either south or north. ನಾರ್ತಿಗೆ ಅಥವಾ ಸೌತಿಗೆ ಆ ಇನ್ಕ್ಲಿನೇಷನ್ ಮಾಡ್ತೀವಿ, ಈಸ್ಟ್ ಮತ್ತು ವೆಸ್ಟಿಗೆ ಮಾಡಲ್ಲ. ಕ್ಲಿಯರ್? ಬಿಕಾಸ್ sun is moving from east to west. So in this case, gamma is equal to 0. If the inclination surface towards the south, now inclination towards south madidre, then gamma is equal to 0, and we have to use this equation: cos theta t, which is equal to sine. Okay, so sine delta sine phi minus s, where s is the slope. We already discussed in the definition. S is the slope, phi is the latitude of a location. So latitude of the particular location. So on the earth surface, okay, so in our Danageri having an one latitude. Okay, so Bangalore having a different latitude. So if you go Kolkata, it is having a different latitude. If you go America or if you go Japan, it is having a different latitude. So particular location on a earth having a particular latitudes. Okay, so that phi refers to the particular latitude ag, that it may be degree. It is measured in terms of degree. And s is the slope. Slope means we already discussed. Slope means the collector angle. So collector is placed at a certain angle with respect to the horizontal. That is called slope. It may be 10 degree, it may be 15 degree, or whatever it may be. Okay, in some cases the slope may be 20 degree. In some cases the slope may be 10 degree. It is a fixed angle. So for that device it is fixed. Okay, and omega. So in the cos delta, cos omega. So omega we already discussed. It is an omega means it is an hour angle. In the definition we already discussed, omega means it is an hour angle. Okay, so hour angle. So every hour angle per hour it is rotating about 15 degree. If it is rotate about 15 degree our earth, it is equivalent to 1 hour. Okay, so w, by using this equation, cos theta t, which is equal to sine delta sine phi minus es plus cos delta cos omega cos phi minus s. This is a standard equation. By using this equation we can find out the whatever the particular that tilted surface inclination. Okay, and for the beam radiation, and this gamma is equal to 0 when it is towards the north, and for horizontal surface theta is equal to theta z. It is the surface azimuth angle. Theta is equal to theta z. and cos theta z is equal to sin phi sin gamma plus sin phi sin delta cos omega. Okay, so this follows the equation. Means if you want to find out the radiation flux falling on the tilted surface, we can use one equation, RB. Okay, radiation, that is what, beam radiation RB, which is equal to HT by H. It is also written as cos theta t, cos divided by cos theta z. So this ratio cos theta t divided by cos theta z, which is equal to a tilted factor. This ratio is called as a tilted factor for only a beam radiation, Okay, we already know that what is that cos theta t and cos theta z. So if you substitute that, and this ratio, whatever the ratio we are getting, RB, which is equal to beam radiation tilted factor, or tilted factor for only beam radiation. So beam radiation, we already know that what is meant by beam radiation. Beam radiation means the radiation which has reached the earth crust, okay, earth surface. There is no diffuse or there is no reflection. Only whatever the pure radiation reaches the earth, that radiation is called as beam radiation, or it is also called as a direct radiation. And next one is diffuse radiation. It is a scattered radiation. Whatever the scattered radiation reaches the earth, that is called as a diffuse radiation. Okay, and which is given by the total ratio of diffuse radiations falling on the tilted surface. That may be horizontal surface, so this is a horizontal surface. It is called as a tilted factor for diffuse radiation. So on the horizontal surface, whatever the scattered radiation is received, that is called diffuse radiation. And diffuse radiation means only a scattered radiations from the sun reaches the earth. It is called diffuse radiation, and its value depends upon the distribution of diffuse radiation over a sky, and a portion of sky it is done seen by the tilted surface. And this diffuse radiation, it is always depends on the sky. If it is a clear sky, diffuse radiation is different. If it is cloudy, or if it is covered by a clouds, then diffuse radiation or diffuse radiations is assumed as a uniform distributed over a sky. Okay, and this assuming that it's an isotropic source of diffuse radiation for a tilted surface with a slope s, and which is given by RD. So RB is beam radiation for a tilted surface. RD means radiation for diffuse, which is given by 1 plus cos S divided by 2. So S is the slope of the receiver or collector, and which is the shape factor or tilted surface with respect to the sky. You just told it is with respect to the sky, this factor, S factor. And next is a reflected radiation or total radiation. Means a beam and diffused component of a solar radiations are observed in the flat plate collector, then it is become a total radiation. Total radiation means it is addition of beam as well as diffused radiation. The angular correction for this has been determined, and a beam radiation is given by the equation. So we have to give some angular corrections. The corrections for diffuse radiations can also applied for the clear day, for it can be assumed that there is an origin is near to the sun. So that is, the scattering of solar radiations is almost or mostly forwarded scattering, and for such a cases R may be assumed equal to RB. R may be assumed to RB, where R is the correction factor for both direct and diffuse radiation, and which can be given by R is equal to HT by T, where HT is equal to R into HB plus HD. Okay, and thus the total radiation such as beam, diffuse, reflected radiations incident on the total surface is given by HT, which is equal to HB into RB, and which is equal to HD 1 plus cos S means slope, divided by 2 plus HB plus HD 1 minus cos S divided by 2 into rho is the density of the atmosphere or cloud. Okay, so atmosphere or cloud. So this value rho value is suggested, it's a diffuse reflection, is suggested by Jordan, Liu and Jordan, which is as follows. So rho, which given by 0.2 when there is no snow. So rho value is 0.2, then there is no snow. Okay, and rho value is 0.7 when there is an snow cover. If it is atmosphere covered by snow or fog, then the rho value is 0.7 because density is more. If there is no density, there is no snow, then rho value is 0.2. So for our India, we generally taken 0.2 as a rho value. For in the most north countries, okay, in Canada, okay, in Switzerland, that rho value is 0.7 because most of the time it is covered by snow or fog. Okay. Uh, So hence there are components of sun, beam radiation, diffuse radiation, and this solar radiations reflected from the ground, which is tilted surfaces, and it are considered, and above corrections are done. So totally this R, I told this R value is equal to HP by H into RB plus HP by H into 1 minus cos S divided by 2 plus 1 minus cos S by 2 into rho. Clear? So by using these equations, we are going to solve some problems. Okay, so that problems are to find out the angle by this beam radiation or as well as this diffused or total radiations. Okay, take a problem on this tilted surface. Calculate the angle made by a beam radiation with normal to flat collector. A beam radiation to the flat plate collector on a particular day, that is December 1, and particular time at 9 a.m. in the morning. Okay, solar time for a location at 28 degree 51 minute in north. The collector is tilted at an angle latitude plus 10 degree. It is a slope. Collector tilted means collector angle is 10 degree, means S is equal to 10 degree. Slope is 10 degree with a horizontal, and it is pointing towards the south. If it is pointing towards the south, already we made that gamma is equal to 0. If gamma is equal to 0 means it is pointing towards the south. Inclination is towards the south. Beginning of the equation only I told. Okay, in the starting I told that. So in the most of the cases we consider that collector angle towards the south. If it is towards the south, then gamma is equal to 0. Then we have the equation cos theta t. The first I told the equation cos theta t is equal to cos phi minus s cos delta cos omega plus sin phi minus s sin delta. And we know that value s value they given. Okay, and phi value also given, the latitude. Phi means what? In the definition I told, it is a latitude. Okay, a latitude of particular location. In this problem, the latitude of particular location is 28 degree 58 minutes in south. Okay, and S is a slope, they given 10 degree, and delta we have to find out, that is what? Declination angle. Declination for that particular day, December 1, I told the declination is varies from minus 23 degree 0.5 to plus 23 degree 0.5. Okay, it is different for different days. In some day it is minus 23, in some day it is 0, in some day it is plus 23. So throughout the day it is, throughout the year it is different. So on particular December 1, so December 1 means it's of if you go with n means so n is the uh, value. Okay, so n it is a number of day. So on particular December 1, in out of 360, clear, out of that 360, that n value is uh, it is approximately 335. Okay, so December 1 will become 335 day, 335 day of that year. Okay, n is the number of day in that particular year. So here December 1 is taken, so that n is equal to 335 days in that year. Okay, so we have the equation. First we have to find out the delta is the declination, okay, on that particular day 335. So delta equation already we discussed in the previous class. So delta is equal to 23.45 sine 360 by 365 into 284 plus n is the number of day. So it is a December 1, so 335. So substitute that, and if you simplify, the delta will become minus 22.10 degree. So on December 1st, the inclination is minus 22.10. Okay, on December 22, it reaches maximum inclination of 23. Okay, but December 1, so it is a less inclination, so minus 22.1. After substituting that, we'll get delta declination value is minus 22.10 degree. And next we have to find out the hour angle. So next we have to find out the hour angle, that is with respect to that hour angle is with respect to the latitudes, okay, slope, latitude, slope, and also the given uh, time. It is particular time as well as particular day and particular latitude or meridian. Okay, so here that hour angle W. So hour angle W, which corresponds to 9 a.m. They given 9 a.m. So for 9 a.m. that omega, which is equal to 45 degree, means on particular 9 a.m. that latitude, for that latitude, that hour angle is become 45 degree. 45 degree. Clear? And we have that equation cos theta x and all the values we got. So phi value 28.58, they given in the equation, okay, 28.58 and minus 38 means slope. Okay, so slope means the tilted slope plus that latitude, so both will add. Okay, so s is equal to that given latitude plus slope angle, so it is become 28.58 plus 10 degree, so it is become 38. So 28 is a given latitude and slope is 10, so if we add that, it is become s 38. Total overall is 38.58. And cos delta, so delta just only we got the value of delta, and cos 45 is the that omega hour angle. Okay, for 9 a.m. it is 45 degree, and again sine 28.58 minus 38.58 degree into sine delta, sine delta, it is already we got to minus 22.1 degree. So substitute, and if you simplify, finally cos theta t, which is equal to 0.7104, and if we convert that into angle, okay, it is in the radian value. Okay, if we convert that, we will got the value of theta t is equal to 44.72 degree. So the final angle, the final angle which is made by beam radiation, which is equal to, for that particular time and particular day with particular location, that angle is theta t is equal to 44.72 degree. So like this you have to find out the values by using given equations. These are the simple equations you have to remember. Okay, there is no derivations for these equations. Simply you have to remember what is the equation for delta declination, what is the equation for this cos theta t, and hour angles we already know that, slope is also know that, latitudes they are given in the problem, and particular day and particular time they are given in the problem. By using all these data, you have to find out the whatever the required data. Okay, so this is a second bit of your second module. This we will discuss in the next class.